Hi, everybody. Hope you're doing great. My name is Vahid, and I would like to solve some data structures and algorithm questions with you. In our previous session, we solved question 141, which was to find linked list cycles. We are going to solve 142, which is a modified version of that question. The big difference this time is that we are trying to return the node where the cycle actually happens. So it's going to make the question a little bit more difficult. Um, in our last attempt, when we were trying to solve the question, we were modifying the linked list, the values of the linked list that we were passing through, but this time we don't want to do that. And we also used hash sets earlier. So that was using memory of O of n. So we don't want to use that approach again. We want to use constant memory this time, not linear memory. All right. So let's check this out. Let's see what has happened here. So we're starting from P and Q. So first of all, we want to make sure that we start from the same node. And to make sure that these two not being equal at the first round wouldn't make this loop to break. I'm gonna modify this code. So I'm gonna check if head or its next element are null. We're gonna return null because we don't have any cycles in the loop. Now we start with P, the slow node, and Q, the fast node. So as long as we haven't reached a null node at the very end, or as long as they're not equal, so this should be an or. Hopefully this will solve that time limit exceeded. We're probably looping through this while loop forever. Or maybe this one. We're gonna check it out. Anyways, so we do this. If Q is null at this stage, then we're gonna return null. Otherwise, we're gonna traverse the list slowly from head while we're also still traversing with the slow node from the location they met. And when they reach there, that would be the location of the beginning of the cycle. All right, let's try this. Okay, it only accepts null asserted values. Although technically they should not be null, but yeah, because we're already checking it here. And we get the time limit exceeded again. Let's see what's the problem. So we're starting from here. We're checking if the head and its next element are null. Oh, okay. So we need to manually do this step. So P should be head next, and so this would be one more step after the initial step. So let me draw it here. So we have 3, and then we have 2, and then we have 0, and then we have -4, and this goes back to 2. All right. So P0 and Q0, the stuff from here. Since we don't want this condition to be an issue in this loop, we're gonna start from the next step. So P1 would be here, and Q1 would be here. So this way, we would not have any problems with this loop. All right. Let's make sure that's fine. I love the fact that Kotlin is so strict about nulls. It just makes life much easier for people who are used to developing code in Java. All right, we're getting the time limit exited again. What could be the cause here? So we got this correct. As long as q.next is not null, or oh, this should be an and. Sorry guys, I have to revert this back. So either the q has reached the null element, or p is not equal to q. And here, if either p is null or its next element is null, then I'm going to return null, which means no cycle has been detected. And it's the same case with here, same on line 15. I'm quite sure that this should solve our problem. Amazing. And we got it correct for all three cases here. But what's the logic here? Why did we come up with this solution? So to show you how we reach that, we're going to keep traversing here. Next step P1 would be here, and Q1 would be, sorry, Q2 would be here. This would be P2. And next step, this would be P3, and this would be Q3. And this is where they meet. Fantastic. So what's the logic behind using this formula, this approach? If you pay attention, if you call this length, let me use a different color, P. Okay. No, sorry. So what's the idea behind this formula, this approach? So if we call this X, and if we call this Y, so X is the location from the head all the way until where the cycle begins. And if Y is the location from where the cycle begins, a location within the cycle where the difference between the location within the cycle and the beginning of the cycle. And if it's Y is the location, and if Y is the difference between the location where the two nodes meet from the beginning of the cycle, we can say that X plus Y, this is the lengths that node P has traversed, and it would be equal to twice two of this length would be equal to the location that node Q is at right now. So that would be also X plus Y plus N C. And C is the length of the cycle. So we can simplify this and say that x plus y is equal to nc. And we are interested in x, okay? So we can say that x is equal to nc minus y. And in other words, you can say that x is equal to n minus 1 c plus c minus y. And c minus y is this length. Let me use a different color here. This is c minus y. So in other words, if we keep moving forward until we reach this point, it would be the same as traversing from the head till the beginning of the cycle. So by using this formula, this approach, that's what we did here when traversing the list linked list, and that's where we reached to the beginning of the linked list, and then we returned p here. So what would be time complexity of this algorithm? At worst case scenario will be O of n, and in terms of the amount of memory that we have used, it would be O of 1. Let's try submitting it. Awesome, and this worked. Pretty good. Well, thank you guys for following me, and I will see you in the next video with another amazing question.